Hello and welcome. My name is Jared Campbell, and I serve as a statewide lead for PaTTAN's Mathematics Initiative. As part of my role at PaTTAN, I am also a contributing partner to the Multi-Tiered System of Supports Initiative. The mission of the Pennsylvania Training and Technical Assistance Network is to support the efforts and initiatives of the Bureau of Special Education and to build the capacity of local educational agencies to serve students who receive special education services. Our goal for each child is to ensure individualized education program teams begin with a general education setting with the use of supplementary aids and services before considering a more restrictive environment. Pennsylvania's multi-tiered system of supports is a standards-aligned, comprehensive school improvement framework for enhancing both academic and behavioral health outcomes for all students. In Pennsylvania, response to intervention, or RTI, refers to the methodology that is used to determine how slow is slow and how low is low, as an alternative to ability achievement discrepancy within the specific learning disability, or SLD, determination process. Pennsylvania's MTSS model represents an integrated system, meaning that cross-disciplinary teams use a problem-solving process to facilitate shared ownership for achieving academic and behavioral goals using a continuum of evidence-based practices and reliable and valid data sources. The academic side of MTSS, standards-aligned, high-quality core literacy, mathematics, and STEM instruction is delivered within the context of culturally responsive practices, positive behavioral supports, and family engagement. There are key components that form the foundation of PA's MTSS framework. If a well-articulated, well-designed tiered system is in place, you should realize efficient, effective, and sustainable outcomes. One of the cornerstones of a multi-tiered system of supports is the systematic use of assessment data to most efficiently allocate resources in order to enhance learning for all students. Essentially, it's about figuring out which students need which supports at what point in time in their learning and ensuring that those supports are provided to students in an effective and efficient manner. You may be familiar with MTSS being represented by a triangle. This is used to illustrate the percentage of students who are likely to need supplemental support above and beyond core curriculum. Once a quality system is in place, about 80% of students should be supported through core instruction and class-wide intervention. That leaves roughly 20% who may be in need of additional support and services. Of the 20%, the majority of students should respond to additional Tier 2 supports when implemented with fidelity. Tier 2 supports are increasingly intensive and often include more time, a smaller group size, and a targeted instructional focus. Tier 3 supports are reserved for a very small percentage of the student population, less than 5%. Tier 3 supports and services are highly customized and are intended to accelerate the student through ambitious growth using the most intensive instructional strategies matched to need. In addition to instructional alterations, the collection and use of data intensifies as well. While students in Tier 1 will participate in fall, winter, and spring benchmark assessments, those students who receive supplemental support in the advanced tiers are monitored much more frequently to determine whether the instructional intensity is resulting in a positive response to intervention. The backbone of a multi-tiered system of supports is the problem-solving process with which we engage. The primary question to answer at Tier 1 is this: is this a class-wide problem? When half or more of our students struggle with a topic in mathematics, this indicates that core instruction did not serve its purpose, and therefore we need to enhance core instruction. This usually results in a class-wide intervention. Because half or more of the students are showing a need, you should intervene with all students. This is the easiest thing to do with fidelity. It prevents your other tiered supports from being larger group sizes. Tier 2 problem solving focuses on individuals and small groups of students and addresses the category of the problem. For example, we have a small group of students struggling with place value concepts. With good Tier 2 support, the general need is addressed. This can be skill specific if you have the data to support, or can be in the form of Tier 2 Lite, which is considered an extension of core instruction and usually centers around additional guided practice or accelerated instruction with the next lesson's content. Tier 3 addresses the causal variable. What is happening with this specific individual that is causing their low performance? Skill gaps, motivation, and other factors are considered at this level. Diagnostic assessments are usually put in place when a student is considered to be in need of Tier 3 supports to help determine the causal variable. Progress monitoring is then used to see academic performance outcome in relation to the adjustments in the variable. It is important to use assessment data for its intended purposes. Many schools use assessments for purposes that do not match their intent. There are 4 general purposes for assessment. The first is program evaluation. This type of assessment takes a global view of achievement. Keystone and PSSA proficiency ratings are a good example of assessments that help us determine the quality of a school's entire system of supports. Universal screeners provide us with a look at individual students and their at-risk nature in terms of future success. Universal screeners can be used as a type of program evaluation for specific grades or classrooms when concerning the health of core instruction. Universal screening data can give you some inclination for general supports for students, but often more assessment is needed to determine the specific needs of students who are struggling. Quality universal screeners also help to identify if there is a class-wide need and point you towards a class-wide intervention. Diagnostic measures provide us with more data that pinpoints the specific needs of a student. Diagnostic assessment occurs more often in the advanced tiers. Always remember, as the supports intensify, the accuracy of the measurement must intensify as well. While formative assessment might be good enough for class-wide interventions, a diagnostic assessment will often be needed to inform Tier 3 supports and services. The fourth purpose of assessment is to monitor student progress. This data is used to see how students respond to instruction and answer questions like, is this intervention working? Or do we need to intensify additional supports? In addition, will this student catch up fast enough? It is beneficial for school districts to organize their available assessments in an assessment matrix to help standardize their use. While some data sources can fulfill multiple purposes, no single assessment will do it all. A matrix will help administrators see redundancy in assessment, reduce the time needed for assessment, and ensure all assessments given fill a specific purpose, while not misusing the data. The purpose of assessment should always be to inform instruction. In this example, this K-6 school uses STAR as their universal screener. STAR will help identify class-wide need and students who are at risk for struggling. For students deemed significantly at risk, STAR and Key Math can be used to diagnose a specific need. Progress monitoring will happen at 2 levels, specific to the skill targeted by the intervention and with a general outcome measure. Skill-specific progress monitoring is more sensitive to growth because it correlates tightly to the focus of the intervention. General outcome measures may only contain 1 or 2 items related to the intervention, but they are linked more closely to the next screener or benchmark assessment. Together, the 2 provide a good data set to determine if the intervention is working fast enough and if it will have the intended outcome on core instruction by eliminating the at-risk status of the student by accelerating the student's learning and progress. This K-6 school uses Spring Math. Spring Math is a comprehensive assessment and intervention system that utilizes mastery measurement as curriculum-based measurement, diagnostic assessment, and progress monitoring to identify whether all students are progressing adequately towards goal skills that meaningfully forecast long-term adaptation and functioning in mathematics. Spring Math also accounts for specific students who need additional supports beyond core instruction and class-wide intervention. Mathematics is a multifaceted, complex discipline. The National Research Council included 5 strands that make up mathematics learning. These strands include adaptive reasoning, strategic competence, conceptual understanding, productive disposition, and procedural fluency. It is important to realize that each strand is of equal importance. Even if you believe one strand receives greater influence on current assessments, each of these strands must work together to build a mathematically competent adult. Conceptual understanding is the knowledge of relationships and ideas that underlie the problem. Procedural knowledge is a developmental understanding of the steps needed to solve a problem. Strategic competence is demonstrated when students can flexibly solve problems using multiple strategies. Adaptive reasoning is the development of learning to justify the correct answer and demonstrate reasoning. Productive disposition brings to light the need for students to view math as useful and worthwhile, while increasing students' confidence. These 5 strands collectively illustrate the characteristics that define mathematical proficiency. Interventions should be matched to students' needs based on data. Not all interventions are created equal, and not all interventions produce results in all areas. For example, if data indicated that a student did not understand a particular concept, running a flashcard intervention would likely have no effect. However, the student could benefit from concrete representational abstract, cognitive strategy instruction, or think aloud interventions. Should the student have motivation issues, contingent reinforcement, goal setting, and self-monitoring are some of the best options. When considering evidence-based practices and professional development, you should begin with interventions that address the most areas. CSI, CRA, explicit instruction, peer-assisted learning, and schema-based instruction cover 3 or 4 strands of mathematical proficiency and would be a good starting place for targeting professional development. This is not a complete list of all possible evidence-based practices. Tier 1. The backbone of quality core instruction is explicit, systematic instruction. This approach is something every teacher needs to be proficient implementing. It begins with identifying and sharing the learning intentions and success criteria. Research indicates that just by sharing what students will learn and how they will be successful produces good gains in achievement. It must be in student-friendly terms. It is not simply a listing of standards. Explicit modeling is what the teacher does to make the mathematics as clear as possible. This includes the use of visuals, cueing key features, think alouds, meaningful context, prior knowledge, and discourse. Guided practice is an opportunity for students to practice what they're working to learn in a setting that is supported by the teacher. Independent practice includes opportunities for students to practice content for which they have already demonstrated understanding. The work is independent of teacher support, not other students. At the end of a math lesson, it is important to summarize to your students how they performed relative to the learning intention based on your observations throughout the lesson. Between class sessions, the teacher does a more complete evaluation of students' overall performance, both collectively and individually, to make decisions about the focus of the next instructional session, including how instruction might need to be differentiated. The inner circle represents the things we should be doing in all aspects of the cycle: specific positive reinforcement, specific corrective feedback, and continuous progress monitoring. Levels of reinforcement and feedback decrease with independence as the skill is built. Even when this cycle is in place, the main issue is the transition from guided to independent practice. It should be the use of formative assessment data that indicates when students transition, not the time on the clock. Unfortunately, teachers often plan their lessons such that X minutes of time are for guided practice and X number of minutes is dedicated to independent work, instead of transitioning students as needed based on their formative assessment data. Providing guided practice should be a flexible and fluid process, rather than thinking of it as always occurring in 3 distinct stages: I do, we do, you do. It will occur differently for different students and for different math content. Consider the figure in the slide. The solid arrow represents the overall direction we want guided practice to go. The two-way arrows indicate times when teachers and students may need to move back to more teacher direction or support, or move forward to less teacher direction and support, depending upon students' responses and what they indicate about their learning. Consider a group of students. They get 10 minutes of explicit instruction. Then there is 10 minutes of guided practice between the students and the teacher. With 10 minutes left in class, all students move on to independent practice, and the teacher spends the rest of the period running around answering questions of individual students, wondering where it all went wrong. Let's reimagine this classroom. At the end of whole group instruction, the teacher has formative assessment data that indicates one student is ready to run, while a few need to check in after trying the first two problems. Meanwhile, the teacher continues to work with a small group to provide additional modeling. After a few more minutes, more students are ready to get started on the first few problems. Some students continue revising their work on the first few problems, and other students are ready for more independence. This illustrates how we could transition students as they show proficiency instead of time on the clock. This will happen at different times for different students. As we reduce the number of students needing more guidance, we create a smaller group size with which we can focus our instructional efforts. Some teachers build student independence through a mixture of whole group instruction and stations. The teacher begins with the whole group. After a short lesson, the teacher takes a small group of students for additional guided practice, while other students are assigned to various stations. Students then rotate through stations, allowing them to experience various instructional activities within the lesson. You will notice that these stations have been organized to include the most important elements of quality pedagogy. In this example, students are at their desks for whole group instruction and the initial guided practice. The teacher then takes a small group for additional guided practice, while other students work independently of the teacher, in small groups or by themselves. As students in the teacher's group demonstrate understanding, they transition into the independent group. This transition continues as students are ready. The initial small group with the teacher continues to decrease in size each time, allowing the teacher to concentrate more on individual students, monitoring their progress, providing positive reinforcement for correct work, and providing specific corrective feedback for issues that students encounter. The purpose of this instructional setting is to allow achievement to dictate when students transition from guided to independent practice, not time. The benefit is that the teacher can focus on students that need additional support. It helps to eliminate those situations where struggling students get lost in a larger group and do not receive the supports that make them successful during the class period. When more than 50% of our students struggle with anything, it is the job of the core classroom teacher to intervene. This means part of our core instructional time needs to be dedicated to providing an intervention to all students. This is one of the most important aspects of building a multi-tiered system of supports for mathematics, yet it is often overlooked. You're thinking, why consider class-wide intervention within core instruction? To which I ask, if you have half of your students in need, how will you ever be able to effectively form small groups and provide the additional resources? The reality is that our time, people, and money are very limited. The easiest thing to do, with the best chance of long-term fidelity and sustainability, is to provide an intervention to all students. If half or more of our students are struggling, we probably didn't do a great job in core instruction before now, and everyone would likely benefit. This problem is a result of core instruction, so the immediate plan is to intervene within core. Class-wide intervention does not need to be overly complicated, but it must target skill gaps common to the majority of students. You should also monitor the progress of all students until the majority of students are successful. This is an outline for an intervention plan that Dr. Amanda Vanderheyden utilizes for class-wide intervention. Students get with a partner to practice and are provided a script. This can be as simple as one student getting the problems and the other student getting the answers. There is a quick recap of the content. Then students take turns completing problems while their partner checks their answers and provides corrections. The time ends with each student completing a timed practice. Data is analyzed, and the group works towards a common goal. This entire process can take place in about 15 minutes. Tier 2. There are anchors for instructional intensity that become variables as we select or plan interventions for students. We have the opportunity to adjust group size, time, quantity, and precision with formative assessment, the accuracy with which we pinpoint content needs, the amount of direction and explicit modeling provided by the teacher, attention to metacognition through strategy instruction, and the amount of opportunities students have to respond. Interventions are ineffective when they become more time doing the same old stuff. Attention to the 7 anchors allow educators to make specific alterations to instructional practices and select better intervention materials. Tier 2 Lite is utilized as a preview and teach of core content the day before core instruction takes place. Tier 2 Lite is reserved for those students who get lost within the confines of whole group instruction and benefit from small group differentiated instruction the day before to give them a leg up the next day during core instruction. These are students who do not have math disabilities, but are less engaged during core instruction and accumulate deficiencies over time due to a lack of engaged learning time. When teachers build in a Tier 2 Lite, they're more successful in reaching the majority of their students through Tier 1 core instruction. When planning this type of small group instruction, it is important to consider the anchors for instructional intensity. This is likely to be a situation where the teacher needs a short amount of time with a smaller group of students to provide explicit instruction with high levels of response opportunities. Tier 3. Tier 3 supports are necessary when the problem-solving team begins to focus on identifying what is causing the issue. The team begins to manipulate variables and monitor progress more frequently to increase the rate at which students are learning. When considering the anchors for instructional intensity, supports need to be more intensive than what can be provided with Tier 2 supports. This often leads to instruction being custom designed and delivered to individual students based on their needs. Tier 3 supports are reserved for less than 5% of the population and are tailored to the unique needs of a given student. This often necessitates the use of reliable and valid diagnostic math assessments to pinpoint where significant deficiencies exist. Tier 3 supports and services also include weekly progress monitoring. The data that is collected is continuously used to inform the problem-solving process toward improved student achievement. It is also common to acquire information about the student's behavioral and social-emotional needs in order to integrate effective practices within a comprehensive treatment plan. Goal setting, self-monitoring, contingent reinforcement, positive relationships, the environment, etc., all begin to play a more important role as we work to catch students up to a point where they are no longer in need of additional supports. The content knowledge and behaviors we teach in Tier 3 must carry over and empower the student to benefit from core instruction. When designing evidence-based instruction, the 7 anchors for instructional intensity must be applied. Interventions that have fewer anchors are not likely to produce the desired outcomes. Finally, it is important for teams to consider establishing quarterly Tier 3 problem-solving meetings with families that are meaningfully engaged in evaluating their child's response to math instruction and intervention, and employing evidence-based strategies at home, given their comfort level and wherewithal. In closing, I would like to revisit some key points from the video. First, any multi-tiered system of supports is about the systematic use of assessment data to most efficiently allocate resources in order to enhance learning for all students. This means students get what they need, and that will not always be the same. You will never be able to have a one-size-fits-all model. MTSS is a research to practice problem-solving model. For an MTSS in math to function, you must have a good system for assessment. Educators already feel there's too much testing, but remember, the purpose of assessment is to inform instruction through progress monitoring, benchmark, diagnostic, and outcome measures. Before funneling too many students in interventions that will decrease the value of that intervention, quality core instruction and class-wide intervention must be in place. With fewer students in need of additional supports, you can begin planning Tier 2 supports that are skill-specific and related to core content, or acceleration to set up students for success with upcoming content. Tier 3 supports are reserved for the most complex situations that require even more time beyond the other supports offered, and are likely designed by a problem-solving team in reference to the specific needs of individual students. When you feel caught up in the ambiguity of establishing or refining your multi-tiered system of supports, always remember it's about getting resources to the students that need them and making sure those resources improve student achievement. For more information and high-quality resources, please visit the Math and MTSS initiative pages at www.PaTTAN.net. My name is Jared Campbell, and I want to thank you for watching this video on multi-tiered systems of supports for mathematics.